Science was always my favorite subject in school, and in college I earned a degree in biology focusing on genetics. I wanted to be a lab tech, but that professional interest changed to personal interest with the birth of my second daughter, Elizabeth. That's because Elizabeth was born with a bilateral cleft palate and cleft lip, and her feet turned in. And when she was 6 weeks old, we received a very unexpected lab result that said she had a chromosome abnormality. Now, Down syndrome is a chromosome abnormality involving chromosome 21, but Elizabeth had a chromosome 18 abnormality. She had a missing piece from the end of the long arm of chromosome 18, a condition called 18q-. And even more depressing, I guess, was the fact that we were told there were only 65 other cases in the world. So, how many genes was she missing? What were those genes? What did they do? And more importantly, how do we make one gene do the work of two? These were all questions that had no answers, but I knew the Human Genome Project was just getting started, so I knew someday we would have the answers to those questions. But of course, the immediate concern was Elizabeth's health. And over the next few years, we went to hundreds of doctor appointments, and she had multiple surgeries. And we learned a lot. We learned a lot about what was wrong with Elizabeth, what was right with Elizabeth, and we learned a lot about treatments that could help Elizabeth. And when she was about 5, a mom called me who also had a son with 18q-. And we talked and we talked and we talked on the phone, and I told her everything I had learned in all those doctor appointments. But she didn't have the same great resources, medically speaking, and she didn't have a biology degree. And so I realized she was not only poorly informed, but she was also very misinformed. And that's when I realized, we need to find those 65 other families. And so that's why we started the Chromosome 18 Registry and Research Society. And I'm happy to tell you that today, of those 65 families, we know of more than 3,000 of those families. And I also made a few trips to the library at UT Health San Antonio to see what was in the medical literature, and there wasn't much, just a few case reports. But like I said, I knew the Human Genome Project was getting started at that time, and that there would be volumes of information about the genes on chromosome 18, in fact, all the genes. And so I wanted to make sure that that information was going to be able to help families. So I enrolled in graduate school. And after completing my PhD in human genetics, I moved on to take a faculty position. And in the 20+ years since then, we have learned a tremendous amount about how to employ standard medical treatments to help people with chromosome 18 abnormalities. And in many cases, these were kids really not thought to be worthy of focusing medical attention on, and in some cases even not worthy of aggressive medical care. But we also want to begin to employ novel therapies based on the specific genes involved. Our goal is to make not only people with chromosome 18 abnormalities have healthy lives, but independent lives. So they're not dependent on other people for their welfare. So chromosome 18 abnormalities are, of course, they're complex. They involve multiple genes, but they're complex. They're not a matter of fate, bad luck, providence. It's just biology gone wrong. And if it's biology, we can figure it out and we can learn how to fix it. And just to make it clear that what we're talking about is not really just applicable to people with chromosome 18 abnormalities, because these are rare conditions. What we're learning is actually applicable to every single living human being. And this is because one of the fascinating things we've learned through the Human Genome Project is that every one of us has a chromosome abnormality. We all have multiple deletions and duplications of our genomes that involve multiple genes. Most of these don't do anything. They don't cause a problem. They're considered normal variants. Some are risk factors for disease, and others cause outright medical problems. And so that's what our research is doing to try to determine which are which. And when we figure out which are the genes that actually cause the medical problems, when you have the wrong number of copies of those genes, that's when we'll turn to drug discovery and try to figure out how to get those genes for one gene to do the work of two. So that's our future. That's where we're going. Our goal is to make the chromosome 18 abnormalities the first treatable chromosome abnormalities because, after all, it's just biology.